Hello everybody, this is Mr. Airsome, and this week we're going to be talking about tectonic boundaries, the boundaries of the plates and the formations that are created when these plates interact. You may remember last week in the packet we talked about Dr. Hess and Alfred Wegener and the idea of tectonic theory, the concept that these massive land masses move around somehow, very slowly, but they move around. And eventually, over time, we understand that they move because of convection. Convection is something that we have already worked on. You may remember the foldable that we made a few weeks ago. But the short version of convection is the rock material in the mantle is near the core. It gets really hot. Because it gets hot, the density drops, which actually makes the material rise. Up here, it cools off and then drops back down towards the center of the earth again. And this cycling of getting hot, rising, getting cold, and falling, this creates a current. And these currents drag and pull the crust from underneath. And when this crust is pulled and dragged, for us, we see it as the movement of the plates. So that's really the mechanism. So what we're going to do is we're going to talk about, okay, all these plates are interacting and touching each other. What's the deal with that? So in your notes, if you just sort of drop down to the bottom, we're going to talk about two types of plates, oceanic and continental. Your oceanic, as you guessed, is going to be something that we find on the sea floor. And it's going to be younger and thinner. Somewhere in the range of 3 to 5 miles thick. Your continental, which is going to be, we'll do this. These aren't really definitions, but we'll call this one your land. These are going to be older. They are going to be much thicker. Anywhere from 20 to up to 50 miles thick. Let's make that a little more clear. Now, if all of these are plates, and some of them are oceanic, and some of them are continental, these places here where they are coming up against each other, we call those interactions. And so any place where two or more plates interact is called a boundary. What we're going to do is draw some pictures of boundaries, add a couple little thoughts to each one, and you're going to use this for the rest of your packet. So, starting off first, a convergent boundary is one of the three main types of plate boundaries. And a convergent boundary basically means that you have two boundaries that are doing this. They're coming towards each other. So, let's go ahead and also write here, towards each other. Towards each other. Now, the first one is going to be your oceanic continental boundary. These are named very simply by what are the two things that are interacting. So an oceanic plate and a continental plate are coming toward each other. Let's draw. Now what I'm drawing here is, and let's put some sea waves here. This right here is an oceanic plate, and it's moving in this direction. This is a continental plate, a big land mass, and it's moving in this direction. And as they're colliding, the continental plate, which is much thicker but less dense, and the oceanic one, which is going to be thinner but more dense, this oceanic plate is going to be forced downward into the mantle. We call this process subduction. And when this goes down into the mantle, this plate is actually going to begin to melt. Remember, the deeper and deeper and deeper we get, the hotter and hotter it becomes. And so this rock that's mixed with all the water as well is going to be underneath here, deep into the planet, and it's going to begin to melt. And as it melts, it will begin to rise, because as we know, things that get hot, their density drops. It's going to rise up, and this actually being formed right here is a volcano. This is how we get volcanoes on land. So let's go ahead and add a couple little descriptors here. There's your volcano. There's your subduction. We've got your arrows here. We're also going to add a little title right here. This is a trench. It's this little divot that we see right there. I say little divot. That divot could be 3 miles deep. Okay? These are really big, deep parts of the ocean when we have subduction occurring. So let's add a couple notes here. This is how we form volcanoes and trenches. This is really prevalent in our area, the Pacific Northwest, and really the Ring of Fire completely. For some context, here's where we are. And the Ring of Fire is something that's pretty well known. It's this entire ring that goes around the Pacific Plate, and you have volcanic action in all these parts of the planet. Your next one is going to be 2 oceanic plates that are coming towards each other. So we're going to have some of the same action here. We're going to have some subduction occurring. And we're also going to get some growth here. But the water, since it's out in the middle of the ocean, is going to be going all the way across. Now, let's go ahead and add our arrows. This plate's moving this way. This plate's moving this way. You've got subduction occurring. And the same thing is going to happen. You're going to have that plate deep down. It's going to melt. And you're going to have stuff rise up. And here we go. Now, this time though, since it's not, on an exposed part of land, it's submerged. What we have here, this is a volcanic island. It's one of the ways we get islands. Subduction's occurring here. Let's go ahead and add a couple notes. This is how we get volcanic island arcs. This is going to be locations such as Taiwan, Japan, part of the Alaskan Aleutian Islands. So I'll put Alaska for now. These are going to be places, these are the Aleutian Islands. That's Alaska. That's an island arc. Your Japan, Philippines, Taiwan, this whole area here, all these islands that are in a line where the islands are all dotting or they begin to merge together. These are called island arcs. Now, it's important to note, this is not how we get Hawaii. Hawaii was formed a very different way, not because of the result of subduction. Okay? The other convergent boundary, there's 3 of these convergent boundaries, now is going to be when continental and continental converge. So now you've got 2 large land masses. And this one's going to be a little different. We're not really going to have true subduction. It may happen a smidge, but sometimes there's just not any at all. You're going to have 2 really big land masses, very thick land masses, pretty equal density. And so we're going to represent it like this. What I want you to imagine is that one giant landmass came this direction, the other one came this direction, and when they smashed into each other, they actually began to sort of fold and push up you could even kind of do this if you want, push up the land into mountains. These are just plain Jane, boring old mountains. No volcanoes, no eruptions, none of that cool stuff, right? Just regular old mountains. So we're just going to put forms mountains. We're also going to add that in this one, there's little or no subduction. Even if there is any subduction, it's a pretty shallow subduction. They're more wedging each other than going underneath and melting. And a famous place for this, always a good example, are the Himalayas. That's where Mount Everest is. It's 11 of the 15 tallest mountains are in the Himalayas. So this is a pretty easy example for this kind of boundary. Let's drop down, move a little faster here on divergent boundary. There's only 2 of them. Divergent, you think of divide these ones are going away from each other. And so we'll put away from each other. And this can occur on land or in the ocean. So let's start with land. Let's say it's continental, continental again. You've got two land masses and they're going away from each other. And sometimes it's hard to draw some of this stuff. So let's do something like this. So we're kind of standing and looking down through what is kind of like a ravine, and you've got your cliffs on either side of you. So if you were standing here, you could be looking down, you could see these two large land masses. Now these are not from the result of erosion, weathering, any of that stuff. These are not those kind of canyons. These are two different plates moving away from each other. And you can go to locations such as this where you can stand and walk literally between two different continents. You can walk between the North American plate and the Eurasian plate. I think that's in Iceland. So what we have here is your land splitting apart. This is going to do a couple key things. This is on land. So this is going to form what we're going to call valley rifts. Valley rifts, okay? And that's what you're going to get. If this splits open, you've got a big gap here, so we can think of it like a valley. It may get filled, okay? So we'll put may be filled with, I could fill with sand, rock, water. This does happen pretty commonly. In fact, sometimes they can become oceans. And one key place that's pretty easy to see this happening, besides Iceland, would be Africa. If you look at an African map, not this one's pretty tiny, but there's a rift that runs all along through here. And you can look at it, and there's big rivers here, there's some massive lakes here, and that's because as the continent is splitting, you have it being filled with water over time. It's called the Great African Rift. The other one we have is oceanic. So you've got two seafloor locations, basically, two plates that are in the seafloor spreading apart from each other. Let's go like this, and we'll kind of lift up a little bit here. Lift up and go back down. Now, something really important happens here. On the continent, remember, it's way thicker, and so as opposed to anything coming up, right, you're not going to get any volcanoes here, nothing like that. You're just going to have it spreading over time, stuff's going to fall in, fill it in. Sometimes in Iceland they have some crazy stuff happening. That's pretty rare. In the ocean, though, remember, it's much more thin, okay? And it's close to the mantle and all this, and so you will have magma come up and begin to fill that gap. Now, we're going to talk way more about this next week, so I'm not going to go into it very much, okay? Let's keep it short and sweet. This is in the ocean, so we call this, it forms ocean ridges. And you have this little lift that we have right here, that's part of a ridge. Like I said, we'll talk about that later. We call this seafloor spreading. And the most famous one of these is the Mid-Atlantic Ocean Ridge, which is about a 10,000 mile long ridge. This line right here is a pretty good indication of where that boundary is. It goes from basically one side of the planet to the other vertically, right? And that's about 10,000 miles long. And if you could go into the ocean and take a look at that, these ridges aren't so small. They would seem like mountains, okay? They can be pretty tall. Lastly, the transform boundary, okay? Now, first you had two plates going to, then you had plates moving apart. Now, sometimes we have plates that just slide next to each other. They just kind of move sideways in opposite directions. And so they're not crashing into or running away from, they're just kind of, there's just friction rubbing between them. This one is just going to be a plain Jane little drawing, so let's just go like this. And another, we'll pretend that's a plate, and that's a plate. I colored out the squares, whoops. This one's going one direction, this one's going opposite direction. And this sliding is going to be occurring right here. And so this line right here, we're going to call that, let's put a little arrow here, we're going to call that a fault. Okay? That is a location where transform boundary is there's friction there, there's slipping, there's faulting that's going to occur there. Now, there's a couple important things. Nothing is formed here. Okay? Sometimes you get some ripples on the countryside, but you're not going to get any mountains, no earthquakes, none of that stuff. You are going to get some shallow earthquakes. Now, all of these boundaries are going to form earthquakes. Okay, if the ground is moving, which they all are, if the ground is moving, then you're going to get earthquakes. These locations, though, you're going to get really shallow earthquakes. The famous place for this is the San Andreas Fault. Andreas Fault. Okay, this is in California. You've probably seen the movies, you've seen all this stuff. There's a fault line right in here that's very, very active and can produce some pretty big earthquakes. The biggest earthquakes, the most frequent big earthquakes are always going to be in these locations when you have these convergent boundaries, because they are two massive plates coming into each other. So you're always going to get the biggest and the deepest earthquakes in these locations. But that's not to say that these transformed boundaries aren't still pretty destructive. They're way more shallow. You're going to have more damage on the land a lot of the times, especially in places like California where the populations in the cities are so big. Okay? Now, as we look at this sheet, you have three key types of boundaries. Convergent, which means going to, divergent, which means going away, and then your transform, where they're sliding side by side. Remember how they're named? They're just named by what plate's interacting. You're going to use this on this week's packet and next week's packet. So when you finish your packet, when you finish drawing these and taking these notes, go ahead and take a picture of that or turn that in however you're going to for this week. You're also going to use it for the PhET simulation this week, and you're going to keep it. Don't throw it away. Keep it so that you can use this information, particularly this one right here. We're going to use this next week. There's a star, I promise. There we go. All right, guys, thank you. Let us know if you have any questions or thoughts about this week's work.